Welcome to our first technical meeting, 2024. Today we'll be talking about machine learning Kaggle. I will not be moving much because otherwise the microphone is not going to be there with me, so you guys wouldn't be able to hear me. Okay, so AI. What is AI? AI is basically the simulation of human intelligence. That's just it. But you're simulating it with computers, and more specifically, neural networks. You're trying to simulate neural networks. And right now, the type of AI we have availability with, and the one we're using, is narrow AI, which is specialized in one specific task. For example, ChatGPT's large language model basically just predicts the next word. That's all it does, right? So it's a specialized one task model. And then we have, this is a theoretical thing where you have general AI, which is also called average general intelligence, which basically can do anything a human being can, just better. But we're not there yet. Introduction to machine learning. Machine learning is a subset of AI, which basically uses large data sets to act. So instead of programming it like you would a regular program, you give it data sets and it quote unquote programs itself, okay, without being explicitly programmed. There's basically three different types of learning. The first way to train or do machine learning is supervised learning. Well, you tell it this is this, so if you see it in the future, keep that in mind. For example, if you have a data, you have a sheet of data, and then one column you have emails, and the other column tells you if that email says spam or not. And then you categorize them. This is a spam, this is not a spam, this is a spam, this is not a spam. And you have thousands and thousands of examples, and you provide those examples to the model. That model will learn what a spam looks like and what a non-spam email looks like. Here in the picture, you can see that we are labeling the shapes, basically telling the model or the machine, this is a square, this is a circle, and then you train it. And then later on, if you ask the LLM or the program, is this a circle? And you provided a circle, it will know that's a circle. The second type of learning is unsupervised learning, which is basically using data that you haven't really specifically said is something. So for example, if at a grocery store, if you see people buying milk, and the same type of people that buy milk also buy bread, then the large language model or the machine learning model will know or will deduce that people who buy milk also buy bread. Or you're not specifically or explicitly telling it that people who buy milk must buy bread, okay? It's learning on its own. And then you have reinforced learning. That's when the system makes decisions by itself, receiving feedback from an action. So this is how they trained a very specific system to play chess, where at the beginning it didn't know how to play chess, and then after 5,000 games, it just learned by itself. So it learns from its mistakes and from the feedback it gets while doing a specific action.
Key concepts. All right, so we have model representation of a learned pattern behavior. So, right, when we talk about a model, that's the thing that's actually doing the grunt work, right? That's what's going to take the data and it's going to present us with something new, right? So think of a model as a sort of equation, right? You give it a whole bunch of numbers and it spits one or two out. That is going to be your model. That's what trains, that's what learns, that's what develops. Features, these are the input variables, right? These features could be anything. We're talking about having a model that predicts housing prices. These could be things like area code, number of houses, number of bedrooms, square footage, garage, all that sort of things. Those are features, right? Those are inputs that go into this equation. Labels, this is the output or prediction that the model makes. right? Models make predictions, we give them inputs, features, it spits out a label. So the training process. So first you have data collection. There's also data cleansing, right? So we get large sets of data. You need to make sure all that data is good. You can have missing data, wrong data. And so how do you go about cleaning, sparsing, and removing any, bad things that are going to ruin your model? So that's the data collection process, right? It's usually the hardest part of the training process is just making sure all your data is good before you go ahead and spit it into your model. Training. So this is the fun part. This is what makes machine learning a fun thing to do. Is it is not nearly as sweating as some other coding you may be experienced with, right? So this is where we import other libraries. We feed it the data. We feed it testing data, or sorry, training data. It spends some time. Usually you'll run. It'll spend 5-10 minutes depending on the size of the data, kind of learning, finding patterns, building that model, building that equation that relates to that data, and then finally you have evaluation, right? So there's different metrics for this. So we give it test data, right? This is data where we know the outcome, we know what it should be, and we test it against the predictions that it makes with those inputs, those features, right? So say I have a house and I know what the price is, I know what the listing price is. Well, then I'm going to have the model make its own prediction given the inputs and see how closely those are. So there's a few different metrics we can use to do that, right? Just taking the difference, seeing how accurate those types of things are, and going that way. So algorithms, there are pretty much two families of algorithms. There is a classifier, right? We do that all the time as humans, right? This is what machine learning does, is it takes a boring human process and it has a computer do it for us based on a whole bunch of training, right? So classification that predicts categories or classes for input data commonly used in tasks like spam detection or image recognition, right? If I send you an email and it's spam, the machine learning model is going to try to look at it and categorize it or classify it as either spam or not spam, right? This is a fairly Boolean process or binary process, right? We look at something, we determine if it is or is not a part of some classification, right? So that's one of the two primary models. That actually, that first graph is fairly similar, right? You see how it kind of squiggles its way through. So we're trying to determine where do you belong, which side of the line do you belong. Then we have regression models. Or actually, let me not leave classification first. The types of input variables you're going to see here are going to be empirical, is that the right term? Empirical data. So these are things like features of a person, place, or thing, that kind of stuff, right? It's not going to be like numbers that we're putting in and then having some kind of output. It's going to be some type of descriptive type inputs, right? Then we have regression models. This is everything numerical, right? This is where we talk about housing prices, stock values, predicting any kind of numerical output from numerical input. So a regression model predicts a continuous numerical outcome, establishing a relationship between input features and the target variables, such as predicting house prices or stock prices. All right, so again, that falls into that lower right picture you see there, right? We're trying to find a trend line of best fit. If you ever, been in a stats class and you input a bunch of numbers and you say find a line of best fit, it's just done a little bit of machine learning for you, right? So these are things that we interact with on a daily basis. Okay, our phones do this, we do this, right? We classify things, we determine things based on inputs.
So like when you're working with like a lot of data and you're trying to evaluate, how do they know that it's working as intended if they have so much data that like they don't go in and evaluate every single case, like the house example you were talking about?
So the way it generally works is there's kind of like a 75-25 rule, right? If I give you an enormous data set and I will say I want to train a new model on this to give me better inputs and outputs, I'm going to split it into about 75-25. 75% of that is going to be my training data. That's what I'm going to use to train my model on. 25% of that is how I'm going to test my model, right? So you're going to scramble that data so it's nice and evenly spread out. You're going to train the model on the first 75% of it or so, and then you're going to test the model on the remaining 25%. And you're going to test it on all of it. And then from that testing, you're going to get a whole bunch of metrics back, R2 scores, there's all these weird nomenclatures and stuff, right? It's going to tell you, hey, how accurate is it to the expected outcome, right? I'm going to give it a whole bunch, like let's say housing prices. Let's say I give it 50 houses. I know the prices, right? I know what I'm expecting it to see. And I have the model make predictions on all of the input variables, and I test it with what I know versus what it gives me, right? And I test it on all of that, and I take some mean average of how accurate those predictions are. There's a whole bunch of different scales depending on whether or not it's a regression model or if it's a classification model, right? Let's say I have a classification model, and I want it to tell me if it's a dog or a cat. I'm going to see how many times is it telling me it's a dog when it is a cat, or vice versa, right? And so I can get it's accurate 95% of the time it's correct. It's a pretty good model, right? Overall, what we should expect. So yeah, you split data into these chunks: test, train, and you see how accurate it is once it goes through that test data. That makes sense? Cool. All right, well, so that's a brief overview of what machine learning is, but if we want to get a more hands-on approach, then we talk about Kaggle. All right, so Kaggle is a platform for data science competitions, learning, and collaboration, as well as a global community of data scientists, research, and enthusiasts. Right, so this is a home base for everything that we like to do and hear what we study doing here at Texas State. Right, they also host competitions like we were talking about earlier. There are regular challenges in diverse domains using real-world data sets, enhances problem-solving skills, and exposes participants to cutting-edge techniques. These competitions range heavily, right? They can be simple competitions, stuff that we'll be looking at here, to competitions that can win $100,000 with the right team, right? And these are posted by Kaggle or by other companies that maybe they have something they want something to do, and they see who's going to do it the fastest and the best. But for the most sake, for this club, we're going to be looking at the learning opportunities and collaboration that we can get out of this, right? So there's a lot of courses on here that are offered for free. That'll help you learn any skills you guys are looking to learn maybe outside of your curriculum in school. All right, so Kaggle tool and resources. So there are data sets and notebooks, diverse data sets for exploration and analysis, and integrated Jupyter notebooks for sharing code analysis and models. Jupyter notebooks is a fun little model that allows you to write code in sections and test it in sections. It's very useful, right? So if I'm learning to import a data set, clean a data set, right? So, categorize it, clean it, improve it, and then put it into my model, train that model, test that model. I can write those code blocks into sections, and then I can test it in sections. So that makes it really useful for when we're first learning how to do new things with coding, right? I can categorize and I can run sections of code. So Kaggle runs heavily intertwined with Jupyter Notebooks. This is a really good learning tool. It's also good for if we need to like retrain a model continuously and I've already downloaded the data, well, then I don't need to download the data every single time I run the model, right? I've already cleaned it, I've already downloaded the data, I've already put it in a spreadsheet, all that good stuff. I don't need to run all those sections of code every single time that I want to run my model, so I can just input certain lines of code. So it's really useful for that. They also have massive data sets, right? When we talk about learning machine learning, the first thing you need is a crap ton of data to do so, right? And I'm not talking like a couple hundred cells, I'm talking like 30, 40, 50,000 cells to get really good, accurate models. So they provide those kinds of resources that give you this playground to train, mess around, and learn some new things. They also offer kernels. These are cloud-based computational environments supporting popular libraries, collaborative space for users to work together, providing feedback and insights. This gives you a lot of access to information that you otherwise wouldn't have, and to technology you otherwise wouldn't have. All right, so what are the benefits? Obviously, the learning resources, interactive courses covering data science and machine learning, all types of data science and machine learning, right? Machine learning is a broad term, but it can be applied to a lot of specific things, and you can find your interest there and figure out what it is that you want to do with machine learning once you spend some time with it. They also have webinars and meetups for diverse skill levels, right? So if you want to meet like-minded individuals or go to events that are sponsored and promoted, this is another great platform to be able to do so. Career benefits, obviously. Kaggle achievements enhance professional profiles, and portfolios showcase skills for potential employers, right? Employers love to see you do things outside of school, right? You guys are all learning very useful stuff in your classes. That's awesome. But they'd love to see that you're doing some stuff on your own time, doing some training. It shows some ambition, and it also shows that you're knowing specific skills, right? Who all in here is ACS major? Okay, right, pretty sound, right? We're all taking data structures, we're all taking OOP, all that sorts of things. That's great. You can go to companies and say, I've taken these things and learned these things, but if you can go to them and say, I have taken this machine learning course, I have developed this machine learning algorithm, I've done these things outside my course that are a little more niche that companies are looking for, that looks amazing. All right, so overall, using Kaggle, getting some of these courses, also some of these courses offer certificates. Those also look great, right? These are things that are proven to show that you have some other skills outside of class that are super useful and beneficial. All right, so what do we want from Kaggle? Again, this is what we've talked about. Well, we want to give you guys an opportunity to have a collaborative learning space to learn, use, and adapt to Kaggle and all the resources that it provides, as well as engage in small competitions that allow you guys to work together, compete with each other, compete with everyone else that's competing on these competitions, and learn a lot along the way.